These have the same instructions as the last one. Find the extrema, find the intervals of increasing and decreasing for the function. So, first thing I'm going to do is find critical points. Where is my derivative equal to 0, and where is it undefined? So, let's see. That's quotient rule. Low, d high, minus high, d low, all over low squared. Squared to the bottom, and away we go. So then, I'm going to simplify a little bit. And what do I get? I get x squared minus 4 minus 2x squared. That simplifies. So what is that? That looks like negative x squared minus 4. Yeah? I think. I'm going to factor out a negative just because I can. Is that true? This will always be positive then, which means this will always be, like, the top will always be negative. And the bottom will always be positive because I'm squaring it. Let's see if that's true. Yeah, I think so. Okay, so here I'm trying to see when it's equal to 0, and in fact, the top is never equal to 0. How do you know that? Well, the only way I could get 0 is if I have this being negative 4, and I can only make that a negative 4 if I have an imaginary number, and we're not going to use imaginary numbers here. So really, this has no critical points for that part, because the derivative will never be 0, but I do have a critical point because the derivative is undefined when x equals positive or negative 2. So my critical points are x equals 2 or x equals negative 2, right? Because if I square that, then it will be 4, and I'll subtract. Am I supposed to subtract? I think so, yes. Sweet. So, those are my critical points. I will do a sign chart, make a sign chart, and see if I have any relative extrema. So we'll start with negative 2, and then I'll go to 2. Those are my those are my critical points. My test points, like toilet paper. Those are gonna be, well, I guess I'll make it a negative 3 and a 0 and a 3. And then sine of k prime. So, if I plug in negative 3, if I plug in negative 3, well, I'm going to plug it into this, because it's the... Actually, I already know. This is always positive. This is always negative because of that. So, that's negative. And, in fact, that's negative. It doesn't matter. It's always negative. It's always decreasing. So I have no relative extrema. Ooh, what happens? I have asymptotes. So that makes sense. But I'm decreasing the entire time. So if I wanted to sketch the graph, what would that look like? Well, it looks like, I mean, that's not part of the problem, but I know that I have asymptotes at x equals positive 2 and negative 2. This is just extra, I think. And I'm decreasing the entire time. So it must look like... This is a complete guess. I don't even know. Well, I guess I would have to decide my end behavior, so I'm not even going to do that. But I do know it's decreasing the entire time. So I would say decreasing for everything. Except for I do have asymptotes, so I have to go from negative infinity to negative 2, and also from negative 2 to 2, right? I'm just stopping at each point, and from 2 to infinity. I'm just decreasing. Yep, that's it. Decreasing. No relative extrema. Actually, no extrema. Absolute or relative. And that's because the derivative never equaled 0, and I don't have any endpoints. I just have asymptotes. Okay.